should. But what have I done here? Okay. Right, a ship is pointing due north and has a speed of 20. The water itself is moving from west to east at 4. Okay, so the ship is going 20 and the water is going this way at 4. What's going to happen? Well, the ship is going to go this way, right? 1 mark. What is the velocity of the ship? So they want, look at this, they want the angle relative to north. So they want you to use this angle. Okay? So this would be square root 416. Right? What is square root 416?
4 root 26.
Ah, no, they want decimal in physics.
20.4.
20.4 meters per second. And then Ben or Khalifa, what is tan inverse 4 over 20? 11.3. So the ship moves at 20.4 meters per second with direction, what do you say, Khalifa? 11.3 degrees to the north. They only care that they see this and this. Did you get that, Ben? Did you get 20.4?
No.
No? Why not?
My problem is English.
Oh, Ben! Ben! This is the first question. Go, did you get 20.4? What are we going to do? The physics exam is in 3 weeks.
No,
I used the wrong
I
number.
draw the diagram.
You drew the diagram right.
Yeah.
You got 20
Yes.
and 4.
Yes.
But you didn't get 20.4.
I draw the vector.
Yeah?
I draw the vector like this vector, but I didn't see the question, the last question. So actually, I know it's easy.
Right. Ben, I give you some advice. Read carefully. Okay? Go. Read carefully. Okay? 4 marks, 4 minutes.
It has some shape.
Some what?
Cheating.
Huh?
This question.
Yeah, question 2. It has some what? Trick?
I don't know what you want to ask.
Is that what you're asking me? Does it have a trick?
Yeah.
I don't think so.
Why you say it?
Because the last question was easy, but you missed this part.
Oh.
So that's why I'm saying read carefully. Don't miss anything. Okay, let's have a look now. When a nail is driven into a piece of wood, okay, so here we go. Here's our wood. Here's our nail. The force here that's being applied down, that is 1100 newtons. And this distance is 1.5. Oh, well, actually, yeah, what happens is the nail moves in, this distance here is 1.5 centimeters here. Okay, so firstly, what's the conservation of energy? So, Gail, what did you say for conservation of energy?
Energy can be neither created or be destroyed.
Good.
By transform from one to another.
Good. What did you write, Ben?
Will not lose and increase. No, I know it's.
Yeah, that's okay. That's not too bad. It's not too bad. Right, what is the work done here? So that's easy. Force times distance. So 1100 times 0.015. What's that, please? What is it? 16.5? Okay. And finally, C. An observer comments that once the object's at rest, the kinetic energy is lost. But it's not lost. What happened? So in other words, this nail had kinetic energy, but now it has no kinetic energy. Where did the kinetic energy go? It wasn't lost. What happened to it?
I thought that was asked for the hammer.
Or the hammer too, yeah, because the hammer had kinetic energy. Yeah, so, okay, everything here has kinetic energy. Firstly, the kinetic energy from the hammer became kinetic energy in the nail. Fine. So what happened to the kinetic energy in the nail? The kinetic energy of the nail was not lost, but, no, wait. I'm asking you to finish this. The kinetic energy of the nail was not lost, but, yes, it was converted to, well, it was converted to many things. Let's list them. Very good, Ben. Heat in the nail and in the wood as well. Okay, good. That's one. What else? B. What potential energy?
Minus 40.
Yeah, I understand what you're saying because it got stuck in the wood. Let's leave that one till the end. What's an easier one first? Let me help you think. Here's a nail here. Okay. Thank you. And let's do your one here. So it's now trapped, isn't it? The nail broke the wood, didn't it? And this means a change in potential energy.
So a whole of them is 2 marks.
No, probably if you say 2 of these, you get 2 marks. So my thinking is, go, if you say 3 of them, then maybe you got 2 of them right and get 2 marks.
So one of them is wrong, it doesn't matter.
No, it's not like that, no. So you should try to write more than 2. Did you say any of these go?
The potential energy.
Okay, so maybe it's only one marked.
And heat.
Oh, good. Okay, so maybe it's two. Yeah.
But I've got the sun's energy.
That's an easy one. Okay. Ben, what did you write? You wrote nothing? Didn't try? Khalifa, did you write anything for this?
Yeah, it was long.
Okay. Let's see the next one. How many marks?
Fine.
Okay, 5 marks. Off you go.
one?
Okay, time up. I see you got some done. Good job, Ben. Okay, so the first thing they want to do is have you draw this. This is energy. This is temperature. And the graph goes like this. Up, flat, up, flat, up. And they want the names here of the graph. So, what's this part here called? This is when the ice melts. So this one here is the melting process.
But also time freezing.
Yeah, okay, so my feeling is they're increasing the energy. So you're moving to the right. But no, it doesn't matter, Ben. This one here is called fusion,
Yeah.
which can mean both melting and freezing. So that's melting or freezing.
So the three answers.
No, I think fusion is enough.
Oh,
Yeah. Here, what's this one called? Evaporation, isn't it? Yeah, which is the same meaning as boiling. Or, so Ben, Gao, and Khalifa, look at, no, wait, English time, wait. Fusion means melting and freezing. So melting is solid to liquid, and freezing is liquid to solid. Okay. Evaporation means liquid to gas or gas to liquid. Okay. Now boiling is liquid to gas. What's the word that's the opposite? Gas to liquid. Do we know it? It's condense is the opposite direction. So in English, oh, look at me, please. No, please look at me. Look at me. Look at me. Look at me. I know it's difficult to look at me. Try to look at me, okay? So melting and freezing, they're opposites in English, okay? For boiling, the opposite is condensing. Okay, did you know this word? Good. Well, did you remember this word?
maybe.
Okay.
Why my mouse is down?
Oh, I spelt it wrong.
Vaporization. There's no E, right?
No, hang on, no, just, wait. There is an E if you use it as a verb. As a noun, there's no E.
Okay. So here's the noun.
Here's the noun, yeah.
So the body can change even.
Second?
The body
Yeah?
can change evaporation.
Yeah, as a verb. Yeah.
Yeah.
But I think
With an E.
So if in the exam they ask us to draw, we only have to write evaporation and fusion.
That's enough, I think, yeah.
it's enough changing.
Anyways, the other thing we have to write is the name of the states. So here it's a solid. Here it's liquid. And here it's gas. Right, so there you go. Look. Solid, fusion, liquid, vaporization, gas. Everything. Okay? Explain, now this question was in version 1. Explain how Brownian motion confirmed the atomic theory. I think this was in version 1. Do you remember Brownian motion? No?
Yeah.
Yes?
Ideal gas.
Yes, it's usually an ideal gas, yeah. But what is... Okay, so English time. Firstly, Brownian, adjective. So it's describing what? Type of motion. Now we have some types of motion. We have linear. Linear motion means straight line. What other do we have? We have projectile. Do you remember projectile motion? It's like this. Remember? Projectile. Okay.
Oh yes.
So, and then of course, what other type of motion? We have circular motion. Harmonic motion. Yeah.
Linear is the best.
So, Brownian is like this. See if it's like this. It's kind of random.
Just one.
Yeah. It's random.
Yeah.
Now, so we've looked at linear, projectile, circular, harmonic, and Brownian. Now, Brownian we didn't really study because there's no equations for it. It's just a word we need to know. So, go. Please.
I was just watching the
No. Explain how Brownian motion provides evidence for the movement of molecules. So you need to explain why it moves like this. So this is what happens. Yeah. Why it's random. Very good, yes. Does anyone remember the reason why? Yeah, go on. I need a key word, a key verb. So, liquid and gas are made of large molecules. No, I don't even have to say large. Are made of molecules because when a large molecule is inside of the liquid or gas, it will move randomly, and here's the key part, because it collides randomly with gas, liquid, molecules. I'll explain that more with a picture. So here is your gas, okay, and here is your large molecule. Now, the gas must contain small molecules like this, because what is happening is the small molecule hits the big molecule, and this makes it move, say, this way. And then another small molecule hits the big molecule and would make it move a different way. So you have this big molecule that you can see. Yes? You have this big molecule you can see. And you have these small molecules like H2O that you can't see. And the small H2O hits the big molecule and makes it move. Makes it move randomly. Okay. So you can't see the H2O. You can only see the big molecule. What's like a big molecule? Like or something like pollen. You know pollen? Do you know pollen? Yeah? Do you know pollen? You can check it on your dictionary.
Was that it called?
Liquid gas are made of molecules because when a large molecule is inside of the liquid or gas, it will move randomly because it collides randomly with gas liquid molecules. You got that word, pollen? Yeah. So Ben, what I'm saying is, if you have a liquid like water, okay, you can't see the H2O molecules, right? You can't see the H2O molecules. But if you put a little piece of pollen inside of it, you'll see the pollen moving around randomly because the H2O collides with it. This is why we think liquid is made of many molecules. Yeah? It's okay, Ben? Go? Khalifa? Yeah? Let's have a look at the next one. 3 minutes. Huh?
We have. Oh yeah, we have.
Do I have a break?
No, I mean
We have 3 hours. We don't need a break, do we, for 3 hours? Because we can finish earlier. Yeah.
Do we have EAP listening classroom? Oh yes.
I don't know.
Finish.
It's okay?
Yes.
Continue? Continue?
Yes.
3 minutes.
Which cases?
Read carefully.
58 is C.
Hmm?
No, I mean the grid. 58, 59. It's C. So it will be 6. No? Mm.
Come here. Is this your cat?
Yeah.
Goodness.
Oh, it's further.
My goodness. You're covered in it.
I don't have time in the morning to clean my shirt.
Did you sleep with your cat? Was it sleeping on you?
No. But, like, he will.
Jump on you? Yeah.
Yes.
Okay, let's have a look at this one now. Did any of you get the first one? What is the similarity and a difference between an electrolyte and a copper wire? So, we can make a table. Okay. Here is an electrolyte. What are you checking? Electrolyte. And here we have copper. Okay. So the first difference, let's do difference first. Copper is usually a solid. And an electrolyte is usually a liquid. That's one difference. Okay. What else is, let's do something that's similar. Copper is a conductor. Electrolyte is a conductor. Okay. What else? Let's do something that's different. So a copper can carry electrons, but an electrolyte carry ions. Okay. Let's give one more. Let's say something that's similar. So let me just mark this down here. This is difference, and this is similar. What else could be similar? Oh, they can. Anything else that's similar? Similar. No, I can't think of any. Yeah. Well, how many do we need to list? They only want one similarity and one difference. So there's one similarity and one difference. I would like to think of two for each, but how else are they similar? Low resistance. Okay, I should get my 2 marks for sure. Okay, next. What is the charge if you have 3 amps for 50 seconds? So what's the formula? Very good. The I is 3 and the T is it 50 or 50? Coulombs. Easy peasy. 1 mark only. 1 mark only. Alright, next one is 3, 4, 5, 6 marks. Go. beautiful. Okay. Finished, Ben? Okay, Ben. What was your first one?
E is different as the force experiment
Yeah.
by particle per unit charge of the particle.
Good, fine. Now, next one. In the region around 4 millicoulombs, there's an electric field. What's the strength at a distance 20? So you have to use the formula E equals KQ over R squared, which is 8.99 times 10 to the 9 times 20, no, times 4 times 10 to the minus 3 over 0.2 squared. And what do you get?
8.99 times 8.
Good man. Sketch the electric field with the equipotential lines. Ah, that's nice for 3 marks. Field.
Huh?
Oh, sorry. Excuse me. Okay.
Oh, I need to write.
Yeah, you forgot those ones, huh? Okay, nice, yeah? Right. 3 marks, 3 minutes, go. Now remember guys, remember my tip, go. If they ask for 1, you try to give 2 because then you can be safe. Just try to give 2.
The UV can we see already?
Can we? Humans? No. But some animals can.
But infrared we can see.
No, we can't.
I would say the formal ones.
For what?
Like we can see it.
Visible.
Yes, I know. This
That's formal, visible.
no, you know.
Yeah. Okay, one's okay, it's okay.
It looks like English exam.
Yeah, this bit is more for English now.
It's not that bad. You know you need to know some English for physics, don't you?
It's always is plan.
Ah, that's easy question. It's good, it's an easy question.
I think UV is dangerous
Correct.
and safe.
Infrared is safe, yeah. Good, let's have a look now. Right, so let's make a table again. What have we got here? We've got infrared and UV. And then how they are the same, and then how they are different. Right, Ben, what did you say for similar?
No is wrong.
Yeah, this is not visible.
It's not live.
Not visible.
Infrared is the left of visible.
Yeah, and UV is to the right.
So, not all the left is visible.
No, only the middle.
Like here.
Yeah, exactly. This is infrared. You can't see this, can you?
But in Chinese, we have like lamp. You can have red
Yeah, well, you can buy special lamps to make it visible, but it's not normally visible. Do you know what I mean? Like, you can't see UV, but you can put on special glasses to see it, you know?
No, I mean the infrared.
No, you can't see infrared. If you see red, it's just normal red. It's not infrared.
Oh.
Yeah. Right, what else is similar? Gao. What else did you say is similar?
They're both.
They both travel at speed c.
What is speed?
Speed of light. They don't need a medium. No material to travel in.
Oh.
Okay, now let's look at how they're different.
But
Yeah?
they are wave. Maybe.
I don't think they'll give you a mark for saying that. It's too easy.
What? It's true.
No, it's true. It's true, but it's too true. All right. How are they different now? What did you say, Khalifa, for difference? No? Go.
Mm-hmm.
How are they different? What did you say?
Safer and danger.
Good. Okay. Which is which?
That's it. Safe. That's danger.
Infrared is
Safe.
safe, and then not safe, unsafe. What else?
Frequency.
Yeah. What's the difference in the frequency?
Low, high.
Good. Low frequency, high frequency. Anything else?
Anything else?
Well, you could say
Length.
high wavelength,
Oh,
no wavelength. Okay. Okay, good. Right. Experiments show that electromagnetic waves can be polarized. What does polarized mean? No? No, don't check. Gao, do you remember what this word means? Polarized? Khalifa? Okay, I'll draw it. Polarized means this. I'll draw it before I explain it. You have many transverse waves in many directions. And then they pass through this polarizer, and what happens is only one wave in one direction passes through. So now you have just one wave and one direction. That's polarization. Yeah? So you have the waves, some are going like this, some are going like this, some are going like this, but when they hit the polarizer, only one of them passes through. Yeah? Alright, so now we need to put this in English. So it means to confine a wave to one plane of vibration. This is the easiest sentence I can use to explain this. Do you know the word confine? Confine means to like force it into one plane. This is called a plane. So you're forcing it into one plane. That's what I'm saying here. Oh, sorry, I should also say to confine a transverse wave to one plane of vibration. Yep. Right, next. 3 marks, 3 minutes, but I think it'll be less than 3 minutes. Off you go. Finished, Ben? Go? Finished? Okay. Which of these is most ionizing? Alpha, beta, or gamma? Alpha, isn't it? And which is most penetrating? Gamma. And what is the meaning of half-life?
So you're taking for half of a nuclear radioactive sample to begin.
Yep, that'll do. There's other ways to say it too, but that's perfect. Ben, what did you write?
Is lose the half wave.
Not half wave. Loses half what? Not halfway. Not enough. More words. Another word. Loses half. Go. What are you doing on your phone?
The question.
Okay, so what did you say for half-life?
I think I
Okay, so put the phone down. So, remember I said when we were talking about writing the lab report, remember I said try not to use it. Okay, so you said, well, say the sentence again, but don't use the word it. Try again, Ben. Like, what is it? You said it loses half the mass. So try again without it.
Material.
Oh, nearly. What type of material? Adjective.
Ionizing.
Not ionizing, no. Radioactive. So you could say the time taken for the radioactive material to lose half its mass.
Half mass.
Yeah, but half mass of the radioactive material.
Radioactive
Material.
material.
Yeah, yeah. Because it doesn't really lose half its mass, because what happens is if you have something like uranium, 10 kilograms, it becomes 5 kilograms uranium and then maybe 5 kilograms lead. So it's only the radioactive part.
They just lose the radiation.
Just the radioactive part, yeah. Yeah. So the mass isn't really gone. Like some of it becomes like lead or, you know.
So
Yeah. Okay, so let's say the time taken for half the radioactive material to decay into a stable material. Oh, I should say mass, shouldn't I? I'll just put it in here. In brackets. Put in here in brackets by mass. In brackets. Yeah.
This question, I think.
Yeah.
Compare the rewrite.
Yeah. Harder.
Definition.
Yeah.
Explain.
I know. And look, here's another one. There you go. 3 minutes, off you go. wrote a lot. We did this very recently.
Yeah, is that quantum mechanics?
Yeah. Okay. A low pressure gas can produce an emission line spectrum. Explain how this proves about the structure, how it provides evidence for the structure here. So here's your gas. Do you remember this? And basically what you do is you heat up your gas. Yeah. Then your gas glows. You pass it through a prism. And then what do you get coming out? You get the rainbow. However, there's something a little bit strange about the rainbow. Do you remember? Some of the colours are missing. Yes? You remember that?
Yes.
Some of them are missing. Now, why are some of them missing? So, this is what happens. The energy levels, or the orbits, of the electrons can take only certain values. The electron can only lose, therefore, the electron can only lose certain values of energy. And then you have to remember the formula. Note E equals HF. So therefore, only certain frequencies of light are made, i.e. the spectrum, the spectra. Yeah? Is that answer okay for you, Ben? Does it make sense? Gail? Clefa? You understand what I'm saying? Right. Mechanics question. So I'll tell you what have we got? 9 and 10 left, isn't it? So look, we'll finish 9 and 10 and then we'll leave it for today. So 9 now for 5 minutes.
What's suspend?
Suspended means hangs. Hangs.
Oh.
H-A-N-G. Sure is. about 20 seconds and then we'll have a look. Finish them. Okay, let's have a look. A suspended string has a natural length of 23 centimeters. So normally it's like this. But when you hang on to it 350 grams, its new length will now be 34 centimeters, because there's a force here of 0.35 times 9.81. Okay, so the first question is, what is the strain? Now, who remembers the formula for strain?
Actually,
Yeah, extension over length. So here it'd be 0.34 minus 0.23 over 0.23. What do you get? Say again?
0.522.
And what's the unit?
Free.
Yeah, what's the word?
Free.
Unit free, no unit, yeah. Oh, my nose. Okay, what's the K? So what formula do I use to get the K? What formula do I use to get K?
F over X.
Yeah, F over X equals K. This is Hooke's law. What's it called? Hooke's law. So that would be F over extension. So what's that?
28.6.
And the unit? You lose a mark for no units.
And over.
Yes. Okay, and then lastly, for this one, when the mass is removed, the spring goes back to its original length. What is this called? Well, yeah, you're right. There's so many words I can think of here. I'm not sure which one they mean. So you're right. You could say this is elastic behavior. How do you spell behavior? B-E-H-A-V. I-O-R? Behavior. Oh, that looks bad.
Hmm?
I see the
O-U-R. I-O-U-R. O.
I'll just write elastic. But that's only one. I mean, there's other words we can think of. Maybe it's elastic. I wouldn't say flexible. What's another word we could say? Say again? Yeah, very good. That's harmonic. Maybe they mean this.
Okay.
No, but I don't know which one they mean. There's another word too.
I want to know the second question.
Restoring. Oh, the second one? The K?
Yeah.
You want to see the answer?
Yeah. 9.81. Oh, that is the tens. I use 10. And how about the X? Why is what's the formula? What was the X?
Extension. The 0.34.
The first string.
Yeah.
String.
Is 0.11 over 0.23.
Yeah.
I think 0.47.
Oh, they told me 0.522. Is it not this?
I got the same thing, 0.478.
Oh, go.
Hmm?
It's supposed to be the first one is 0.34 minus 0.21 equals to 0.11.
Look
Then
at it.
down 0.11 over 0.23 to give us 0.478.
Why 12?
It's not 12.
No, it's not.
Oh, 34. Yeah, 30.
It's 11, isn't it? Yeah, go.
Sorry.
0.478. Thank you, Ben and Khalifa.
And
Yeah, that's why it's wrong though.
And this is wrong as well.
I used the 12.
Ah, go. 31.2. Thank you. Okay. If you had to pick, which word do you think they went for to describe this behaviour? Elastic, harmonic, or restoring?
Something about Baba, so I'll go for elastic.
You go for elastic. That's one vote. Ben, what do you think?
no, I say harmonic.
Okay, that's one vote. What do you think?
Maybe elastic.
Okay, that's two votes. I kind of feel like restoring. So let's. I want to check. Let's check the answer just to see.
They say both.
All three. Let's see. Then we have just one question left to do. Are you opening the answer? Gab? Are you opening the answer?
Yeah.
Okay, you can open the answer. I don't need to then.
Elastic.
They went for elastic.
Yep.
Great. Who said elastic? One of you said elastic. Two of you said elastic. Who said elastic? And who else? Okay. Sorry, Ben. We don't get the mark. Okay. Last question. 4 marks. 4 minutes.
What's mean incidence?
I.
Huh?
I and or. The two angles. Theta 1. Incidence means theta 1.
and incidency.
Yeah, the first one is a verb, and the second one is a noun. Okay, let's have a look. So the first one, what formula do you use? Use the formula N equals C over V. And they want the V. So V equals C over N. That's 3 times 10 to the 8 over 1.43. And what do you get?
2.10 times 10 is.
Did you get that? Yeah, you got that. Good job, Khalifa. Ben, did you get that? Good job. Okay. What is the angle here? So now we use the formula sine 20 over sine theta, and this one is going from glass, or from air to glass. So that's 1.43 over 1. So theta is sine inverse sine 20 over 1.43. What's that?
13.8.
Say again?
13 plus 8.
Yeah? Okay. And what's the critical angle? So lastly, the critical angle is sine inverse 1 over 1.43. And what's that?
44.4.
Yeah. It's okay, isn't it? Let's see. Okay, let's close this. No? Yep. Now, how many hours do we have tomorrow? 2. Okay, good. Might.
We have 4 hours, 4 times 5.
Because it did 5 hours.
Yeah, 5 hours. No, 1 hour is for nail. for the assessments.
Oh yeah, 1 hour.
But it's